we want to find x bar, y bar. We can switch the coordinate system or the origin if we want, but I recommend if one's given to you, just to stay with it rather than trying to translate all of the values. So what we can do is I'll just copy exactly this shape, and then I can divvy it up into the smaller shapes. So they tell us this is 3 inches, and then 4 inches. This has a radius of 3 inches. And then that's also 3 inches. We want to split it up into those discrete shapes that we know the centroid of and we know the area of. So what is at least a way we could break this up into smaller pieces that are easier to handle? This entire outer rectangle here as a solid shape, and then to make up for the fact that we included stuff that wasn't supposed to be there, we'll cut out this triangle and cut out this quarter circle. So I'm going to call that outer shape, that rectangle, I'll call that shape 1. And then I'm going to remove this and remove that from it. And so it lines up with my notes. I called the triangle piece shape 2, and I called the quarter circle shape 3. Again, not the only way we could have done this. I could have broken this up into like a triangle here, and then a rectangle here, and then this rectangle, and then cut out that quarter circle. But that would have been 1, 2, 3, 4 shapes. Because I'm filling out that table, the fewer shapes I have to make, the fewer rows I have to fill out. And it's less work that way. But we'll get the same answer with any, as long as we're splitting it up correctly, we'll always arrive at the same answer. With these 3 shapes, I now can start filling out or creating that table. So each shape gets a row, and then we'll have a summation row at the bottom. Each shape I need its area. This will be in square inches. It's x tilde measured from the origin. That'll be in inches. It's y tilde. And then the products. And we don't add these columns together. We only add the products and we add the total area together. For shape 1, that outer rectangle, that solid rectangle, is going to have a height of 3 inches and 3 inches, so a height of 6 inches, and it has a base of a total of 10 inches. I'll put a little bit more detail how we're measuring this. 10 inches by 6 inches, so a total area of 60 inches, 60 square inches. We then cut out from that shape number 2. That will then get a negative area. Shape 2 has a base of 3 inches, and it has a height of 3 inches. So 1/2 base times height will be a negative 4.5 square inches. And the quarter circle shape 3, we're also cutting out. So remember, give that a negative area. For a full circle, its area will be pi r squared. So since it's a quarter of a circle, it will be 1/4 pi r squared for the area of shape number 3. It has a radius of 3 inches, so we get 1/4 pi times 3 squared. We get about negative 7.07, rounded off. Now, keeping track of the proper sign on everything, I'll get 60 minus 4.5 minus 7.07. The total area then of the yellow shaded region, 48.4 square inches. Now I want my x tildes and my y tildes for each shape. Shape 1 will at least be easy because it's just a big rectangle. In the x direction, I have to go half of its base. Since its base is 10, then from the origin here, I have to go to the right by 5 inches. Once I'm there, I have to go up by half of its height to get to its centroid. So I have to go up by a total of 3 inches. Now I can look at shape number 2. I have to go in the x direction by 1/3 of its base from the right angle. So since its base is 3, I have to go from the y-axis 1 inch to the right. So its x tilde is 1. How far from the origin do I have to go in the y direction to get to its centroid? Right, I have to go 5 because from the right angle I go 1. But from here, that's then a total of 5 inches. So 5 inches from the origin for shape number 2. And finally, shape 3, the quarter circle. This one's a little bit trickier to remember. Go back to the picture for our quarter circle. For the quarter circle, its centroid from the flat ends is 4r over 3 pi. So for our shape in the x direction, its centroid is located somewhere around here. It's going to be 4 times 3 over 3 pi from this end, and 4r over 3 pi from that end. But again, we have to measure from the origin, so I have to take 10 minus that 4r over 3 pi to get the distance from the y-axis to get to its centroid. So for the x tilde, that is going to be 8.73. Again, that's 10 minus 4 times 3 over 3 pi. And for the y direction, it's that same 4r over 3 pi, but it's going to be 6 minus 4r over 3 pi to get from my x-axis to the centroid of shape number 3. I get 4.73 for that. Questions on getting the centroids for my 3 individual shapes. Yeah, I want to reiterate this because it's a common mistake. We're measuring everything from that common origin. We're not measuring it from the corner of the shape or from the base and the height of the shape. We have to take that into account, but ultimately it's measured from the origin of the system. The easy part now, I just have to multiply across my rows. 60 times 5, I get positive 300. I get negative 4.5. And I get negative 61.7. Adding up these 3 values, I get 233.8. 60 times 3, I get a positive 180. Negative 22.5. And negative the 7 times the 4.73, negative 33.4. And when I add these 3 values together, I get 124.1. Last step, my total AX tilde divided by my total area. My X bar, I get a positive 4.83. And that's in inches. And Y bar 124.1 over 48.4 is 2.56 inches. So again, not really to scale here, but about here in the x direction, a little bit before halfway, and then a little bit below, if this is the midline, so somewhere about there, I get the centroid of this composite shape.